Hi, in this lecture, I'm going to talk about multi-layer network operations. Now, I start with this example where you see 4 different type of networks are connected through 3 type of routers. Network 1 is an Ethernet network, and as you can see, host computer 1 is connected to router 1 through Ethernet, and router 1 connects to router 2 using a wireless local area network, Wi-Fi, which is that for this example. Now, router 2 connects to router 3 through a protocol called point-to-point protocol, for short PPP. And that is a low data rate protocol, but it's connected through a wire in this example. Next, router 3 connects the PPP it turns it back into an Ethernet protocol, connecting it within the Ethernet network, which is network number 4. So now, what we want to do is, we want to connect computer host 1 all the way to the computer on the other end, which is computer host 5. How do we make that happen? First, we start with this. You look at computer 1, which is host 1, and we look at the receiving end, which is host 5. What happens? This shows the application layer, the TCP layer, the IP layer, and the network access layer. Here, the upper layer is supporting application X. Application X is used where a part of the overall data set, one segment is cut and is set as a data size right here. And then TCP takes that data segment and attaches a TCP header. Next, IP attaches its IP header at the IP layer. Then, in order to be ready to be sent out through the Ethernet network, what Ethernet will do, it will attach its own header to the packet and prepare it for transmission. Now, Ethernet then sends it out through the network, which is received. And you can see that router 1 receives it through that connection. Then, router 1 will send it to router 2 through Wi-Fi. Router 2 will send it to router 3 through PPP. Router 3 will then receive it and send it in network 4 so that it can be connected to host 5. Then, when it's received at computer host 5, the first thing that happens is that the Ethernet header, IP header, TCP header, and data are all together. The Ethernet header will be used to be delivered to host computer 5, but when it puts it back, when it returns it, when it gives it to the IP layer in host 5, it will remove the Ethernet header. Then the IP layer will check the entire packet and the IP header, and then it will remove the IP header, and then the TCP header and the data segment is delivered to the TCP layer. TCP will look at the TCP header, check things like the sequence number and other things, and then it will also look at the host computer port number. And the port ID will indicate that this needs to be delivered to application X. Then TCP will use that to deliver this to application X in host computer 5. This is the multi-layer process that is done to a packet that is sent throughout the network. Now, in this example, you see what is done within computer host 1 and computer host 5. What goes on between host 1 and router 1, router 1, router 2, and between router 2 and router 3, and between router 3 and host computer 5. That's shown in this picture right here. Well, once that Ethernet packet that host 1 sends out, it has an Ethernet header, IP header, TCP header, and then it has the data part there. Now, this is sent through Ethernet, but what happens is that this packet, the Ethernet header is taken off, the IP packet part, which is IP packet, TCP header, and data part, is given to the IP router layer in router 1. Then what it will do is that it will exchange the Ethernet header to a wireless LAN header, a Wi-Fi header, and then it will send it out through router 1 to router 2. This is all going to be a Wi-Fi wireless connection. And that's what you see right here. Now, this Wi-Fi packet is okay, meaning that Wi-Fi uses a big packet size. It permits a big packet size. So therefore, the Ethernet packet was transferred over the Wi-Fi network using the same packet structure. All that it needed to do was change the Ethernet header to the Wi-Fi header. And that was okay. However, now router 2 needs to connect to router 3 using the PPP protocol. Now, this is where a slight change in packet shape, packet format needs to occur. Why? Because the maximum transfer unit, which is the maximum packet size that is permitted in the PPP protocol, which is used between router 2 and router 3, this is much smaller compared to what Wi-Fi is using. So therefore, now what we need to do is packet fragmentation. We need to divide the packet into multiple packets. I'm going to say this first, that this is only possible in IPv4. IPv6 does not allow you to do packet fragmentation, but we'll talk about that later. Now, in this example is IPv4, and packet fragmentation is permitted, so now we divide the packet into 3 packets. The way that we divide it is, the first part is 512 octets, 512 bytes. The second part is like that as well, and the remaining part is put in the third packet. And instead of the Wi-Fi, the wireless LAN header, we change that to a PPP header for all 3 segments of the packets. In addition, you need to know that the IP header needs to be included in all 3 of these fragmented packets. Remember, without the IP header, you do not know the source and destination IP address, and therefore they cannot be delivered throughout the network any further. The packet can only move around within the same protocol if there is no IP packet header. And that's not what we need. We need to go from PPP, and then we need to go to the Ethernet network in network 4 again. So we need these IP headers. That's why the IP headers are all included. And anytime you do packet fragmentation, the IP headers are always included in every single IP packet. In every single packet, we always need an IP header. But the TCP header does not need to be repeated in all of these 3 packets. So that's why you see only the packet on top has a TCP header. Now, these 3 packets are sent through router 3 to host computer 5. In this process, the Ethernet protocol has a much larger maximum transfer unit. So therefore, these individual packets, their header is changed from PPP to Ethernet headers, and they are delivered in network 4 to reach computer host 5. And then the packets will go up the chain as shown above. Now, this slide shows you how really the packet headers look like. To start with IPv4, it's not a simple structure. There's quite a lot, and the minimum header size of an IPv4 packet is 20 bytes, 20 octets. Now, in TCP, the TCP header is shown here, and the minimum TCP header size is 20 octets as well. And underneath, you see the Ethernet header and the wireless LAN, the Wi-Fi header. Ethernet actually has a header and a tail to the packet structure. Wi-Fi does that as well. And we'll go into the packet structures later in another lecture. And this is the structure of actually what is added to the front and back of these packets to make our packets go through the Ethernet, wireless LAN, and other networks as well. The references are on the next page, and also I recommend for you to look at them if you want to study the details in further. Thank you.